is more from a Six Sigma perspective, which was defined by Motorola. What is Six Sigma? So when Motorola developed the Six Sigma concept in a statistical way, they defined the Six Sigmas. The customer specifications are away by six standard deviation from the mean, and a Six Sigma process produces only 3.4 defects per million opportunities. So this was the definition which was given by Motorola in a statistical way. So I'll explain you what is this definition of Six Sigma in a statistical way, what it means. So with an example. So this is an example of a order fulfillment process. When we say order fulfillment, the time a customer gives an order and till the customer gets the order, the time the order fulfillment is that process where from the time the order is given till the order is dispatched and the customer receives the order. So it is called as the order fulfillment process. So it can be any product or it can be any service that the customer is asking. So the order is being fulfilled by this process. And when we took last 6 months of data to look into the from the customer order, how much time it is taking to give those product. It can be a laptop, it can be a machine, or it can be a pump, it can be a document, or it can be a proposal. So it can be anything that the customer is asking for. So order fulfillment process is can any order which is given by the customer or any product or any service, how much time it is taking to this. So we can say the average time taken from last 6 months of data. I'm just giving some assumptions here. Last 6 months of data when we took and we calculated by equations, the mean value, the average value is 45 days. The standard deviation was 5 days. So it is giving this mean and standard deviation. And when we plot this graph or this and their time, the order fulfillment time in a histogram. So the order fulfillment time was given in a histogram where the x-axis are the order fulfillment time and y-axis as the frequency. That's called as a histogram, which I'll show you later part of the day, how a histogram. So this is a concept called as a normal distribution of the data, where we are trying to see that how the distribution of data is in a histogram. And when we asked the customer said that the maximum time they can wait for the product is 60 days. We call that as the upper specification limit. So the minimum time they can wait for the product is 30 days. So we call that as a lower specification limit, or call as LSL and USL. So when we look into this process, and create a histogram, and in this lower specification limit and the upper specification limit is plotted in a histogram. The mean is 45, upper specification limit is 60 days, and lower specification is 30 days. In the histogram, so this concept was explained by a person called as Frederick Gauss, called as a normal distribution concept. In the histogram, the first increment from the mean value will be mean plus one standard deviation. So mean is 45, one standard deviation is 5. So it is mean 45 plus 5, 50 will be the first increment in the x-axis in the histogram. The second increment will be mean plus 2 standard deviation, that is 55. So the next increment will be mean plus 3 standard deviation, that is 60, then 65. So like that, it will be on the right side from the mean, the increment will be an addition of 1 standard deviation. And on the left side, the histogram, the increment will be 1 standard deviation less than the mean. So it is 45 minus 5, 40, 35, 30, 25, etc. So on the left side, it is going to be 1 standard deviation always. The increment will be 1 standard deviation less than the previous increment. So from the mean value, 40, 35, 30, 25. On the right side, it is 50, 55, 60, and 65. So when I look at the histogram with a lower specification limit, 30, and the upper specification of 60, when the Motorola defined the sigma level of the process, so it said that how many standard deviations are there between the mean and the specification limits. So the upper specification limit is 60 days. So one standard deviation is 50, two standard deviation is 55, and three standard deviation is 60. So we can say that upper specification limit is 3 standard deviation away from the mean of the process. Similarly, the lower specification limit is minus 1 sigma or 1 standard deviation is 40, minus 2 standard deviation is 35, minus 3 standard deviation is 30. So we can say that lower specification limit is 3 standard deviation on the left side from the mean. So it is minus 3 standard deviation is the USL. I mean LSL. USL is plus 3 standard deviation on the right side. So that is how the Motorola described a quality of a process by looking into how many standard deviations are there between the mean and the upper specification limit and the mean and the lower specification limit. And that is where in a 3 sigma process, the USL and the LSL, the upper specification limit and the lower specification limits, are 3 standard deviations away from the mean of the process. Then a process is called as a 3 sigma process. Both need to be 3 standard deviations away from the mean of the process. In a 6 sigma process, both USL and LSL would be 6 standard deviations away from the mean of the process. So that is where this is how Motorola developed that the customer specification limits. So this customer specifies the upper and lower specification limits. So that's why it is called as customer specification limits are away by 6 standard deviation from the mean of the process. So in a 6 sigma process, the upper specification limit will be 6 standard deviations away from the mean, and the lower specification limits will also be 6 standard deviations away from the mean. So both have to be 6 standard deviations away, then only it is called as 6 sigma process. So 6 sigma process is called as defined by Motorola as a world-class process performance is achieved when the 6 sigma performance is achieved. The 3 sigma is just for your understanding. So a 3 sigma process is just for your understanding that when a process is called a 3 sigma process, so a USL and LSL will be 3 standard deviations away from the mean of the process. So every process will have a sigma level, and how to find it, I'll teach you in the next modules. So when I look into a process, a 3 sigma process says that the mean is 3 standard deviations away from the mean of the process. Similarly, in a 6 sigma process, the USL and LSL both would be 6 standard deviation away from the mean. So this is a definition which was given here in the previous, the customer specifications away by 6 standard deviation from the mean. So this was defined with an example. I have this defined as with an example here. Using a histogram, we are seeing the distribution of the data, and we are seeing that how far is the mean from the specification limits. So in a histogram, we are trying to see the sigma level of the process. So a sigma level is the number of standard deviations between the mean and the specification limits given by the customer. So each customer, or when we ask the customer, we'll see what the specification limits. So based on that, we can define the sigma level of the process. We'll see that in detail in the measure phase. We'll be looking into this in detail. So this is just for your understanding. So what is a definition of sigma level of a process? In a 6 sigma, we say customer specifications are away by 6 standard deviation from the mean. And Motorola also said that a 6 sigma process produces only 3.4 defects per million opportunities. So Motorola said that any output going beyond the upper specification limit is called as a defect. So any order fulfillment happening after 60 days is a defect. Or from a 6 sigma perspective, when the customer says that they are willing to wait for 30 days as a lower specification limit, any order fulfillment done before 30 days from a 6 sigma perspective, it is a defect from the process. So this is what is a defect. So defect is anything which is not meeting the customer specifications are called as defect. So we can say any order fulfillment happening after 60 days is a defect. From a Six Sigma perspective, any defect happening before or any procurement before 30 days is also called as a defect because the customer says that their tolerance limit is between 30 days and 60 days. So the process should be between the 30 days and 60 days should be our order fulfillment. So that is we call as the tolerance limit. The customer is tolerating the process within the lower Susi limit and upper Susi limit. So anything beyond it is called as a defect. So Motorola defined the defect and said that a Six